Alright, so today we're going to go through the 2013 HSC physics paper. This is for module 6, inquiry question 2, and we're looking at two parallel conductors or three parallel conductors and looking at what kind of force is acting on them. So in this question we have PQR, straight current carrying conductors. Conductor P and R are fixed and unable to move. Conductor Q is free to move. So can move either this way, up or down, stuff like that. In which direction will the conductor Q move as a result of the current flow in P and R? Now, if we look at this, really simple. We have two wires going in the same direction, or the current of the two wires going in the same direction. So we'll see an attraction force. So that's going to bring Q to the left. We also see that Q and R, the currents are going in the opposite direction. So that's going to cause a repulsive force. So that's going to drag Q also moving to the left in this direction here. So the overall direction change we'll see is Q will go to P, or you could say simply to the left. So that's what we have there. The next question we have is calculate the magnitude of the force experienced by Q as a result of the current through P and R. So here we're looking at the magnitude. So you're not looking at, in total where the force is dragging Q, just the entire thing together. So let's look at on our formula sheet. The thing that we'll use, or the formula that we'll use, is F equals 1 over 4 pi epsilon. Oh, wrong equation. So F over L equals to mu naught 2 pi I1 times I2 over R. So that's the equation we're looking at. So we're going to find a scenario where it's P to Q and P and R. So we're going to look at the forces being projected on it there. Okay, so let's look at what stuff was given to us. We're given that L is 1 meter. We're given that R, the distance, is 5 millimeters, or 5 times 10 minus 3 in meters, and then 2.5 10 to the minus 3 meters there. Okay, so that's what we have. So I'll do the two numbers separately, and we'll see what we get. So the force that we have, and this is between P and Q, the force is given by mu over 2 pi. Now, according to our equation, or according to our data sheet, mu naught is 4 pi times 7 to the minus, or 10 to the minus 7 over 2 pi times the current, which is 6 times 2, and a distance separation of 5 times 10 to the minus 3, and then times that 1 meter. Okay, put that into your calculator and see what you get. And the overall force this experiences is 4.8 times 10 to the minus 4 newtons. That's how much force is being experienced by the two. If I then look at the one being experienced between P and R, we'll get a slightly different answer. So between, or Q and R, sorry, between Q and R, again, we just substitute in the same starting numbers. The current was 2, and the other one was 2 as well, there was a separation of 2.5 times 10 to the minus 3 meters, and then times 1. So the total newtons of force experienced in this case is 3.2 times 10 to the minus 4 newtons. So in total, if you add this one and this one, the total amount of force, so F total, is those two numbers added together. And that will give you 8 times 10 to the power of minus 4 newtons. That's the total force you have in that way. If you then were to look at, maybe if it was looking at the sum of the forces experienced, then you would have to consider where the vectors are going. But it wouldn't really matter because they're both dragging the object to the left in that case. Okay, so that's how you do the question there. A little playlist of all the other questions from inquiry 2. Anyhow, that's how you do the question. Have a good day.